Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of web cache poisoning. This is a fascinating and often overlooked area of web security. I'll provide a detailed tutorial covering the methodology, real-world examples, and code examples, where appropriate. Keep in mind that ethically hacking and testing without permission is illegal. Only perform these tests on systems you own or have explicit permission to test. What is web cache poisoning? Web cache poisoning, WCP, is a type of attack where an attacker crafts a malicious HTTP response that is cached by a web server's cache. Subsequently, when other users request the same resource, they are served the poisoned, malicious, response from the cache instead of the intended, legitimate content. This can lead to a wide range of attacks, including defacement, replacing website content with attacker-controlled content. XSS, cross-site scripting, injecting malicious JavaScript code into the cached response, potentially stealing user credentials or performing other actions on their behalf. Information disclosure, leaking sensitive information that was not intended to be cached. Redirection, redirecting users to a malicious website. Session hijacking, injecting malicious code to steal session tokens. Why does it work? Web caches are designed to improve performance and reduce server load by storing and serving frequently requested content. However, they sometimes make incorrect assumptions about which parts of a request are relevant for determining the cache key. The cache key is the unique identifier used to store and retrieve a response from the cache. If an attacker can manipulate a header or parameter that is not considered part of the cache key, but is processed by the backend application, they can influence the response and have it cached. Subsequent requests, even if they don't include the malicious header or parameter, will receive the poisoned response because the cache key matches. Understanding key concepts. Cache key. The unique identifier used by the cache to store and retrieve responses. Typically composed of the request method, example get, post, the URL, and potentially specific HTTP headers. Cache hit ratio. The percentage of requests served directly from the cache. A higher cache hit ratio means better performance. Cache TTL, time to live, the duration for which a cached response is considered valid. After the TTL expires, the cache revalidates the response with the origin server. Cache invalidation. The process of removing a cached response from the cache. This can be done manually by an administrator or automatically by the cache based on certain events. Web cache poisoning hunting methodology. Here's a step-by-step approach to identifying web cache poisoning vulnerabilities. Phase 1, Reconnaissance and Target Analysis. 1. Identify potential targets. Focus on websites that use caching mechanisms, example CDNs like Cloudflare, Akamai, Fastly, or reverse proxies like Varnish, Inc.'s caching modules. Look for the cache control, H, vary, and X cache headers in HTTP responses. Target dynamic content, especially content that is personalized or depends on user input. Consider APIs or endpoints that return JSON or XML data. 2. Map the application's structure. Explore the website thoroughly, identifying different pages, functionalities, and input points. Use a web crawler or spider to map the application's structure and identify all accessible URLs. Pay attention to URL parameters, headers, and cookies used by the application. 3. Identify caching mechanisms. Examine HTTP response headers to determine if caching is in use. Asterisk look for headers like. Asterisk cache control, indicates caching directives, example public, private, max age, no cache. Asterisk age, indicates how long the response has been cached. Asterisk vary, specifies which request headers are used to determine the cache key. If vary, user agent is present, the cache key considers the user agent string. Asterisk xcache, indicates whether the response was served from the cache, hit, or the origin server, miss. Asterisk CDN cache, similar to xcache but specific to some CDNs. Asterisk surrogate control / surrogate key, related to surrogate caching used by some CDNs. Asterisk use online tools or browser extensions to analyze HTTP headers. Asterisk use curl from the command line. The V option displays verbose output, including HTTP headers. 4. Fingerprint the cache server asterisk. Asterisk try to identify the specific caching technology being used, example Cloudflare, Akamai, Varnish. This can sometimes be inferred from the server header or other response headers. Asterisk understanding the caching technology can help you predict its behavior and identify potential vulnerabilities. Phase 2, identify unkeyed inputs, cache key determination. This is the most crucial step. You need to figure out which parts of a request are not considered part of the cache key. The goal is to find headers or parameters that influence the backend's response but are ignored by the cache. 1. Basic cache key identification asterisk. Asterisk start by assuming the cache key is simply the request method and the URL. Asterisk send the same request multiple times and observe the xcache or age headers. If xcache changes from miss to hit and age increases, it indicates that the response is being cached based on the URL. 2. Header fuzzing asterisk. Asterisk this is the core technique. Send requests with various non-standard or uncommon HTTP headers. The goal is to find headers that influence the response but are not part of the cache key. Asterisk use a tool like Burp Suite with the Turbo Intruder extension to send a large number of requests with different headers very quickly. Asterisk example, Turbo Intruder script. Asterisk this script iterates through a list of potentially interesting headers and adds them to the request with a malicious value, example evil. Asterisk monitor the responses for changes. 3. Parameter fuzzing asterisk. Asterisk similar to header fuzzing, try manipulating URL parameters. Asterisk add, modify, or remove parameters to see if they affect the response. Asterisk pay attention to parameters that are used for filtering, sorting, or pagination. 4. Vary header analysis asterisk. Asterisk the vary header indicates which request headers are part of the cache key. If a header is not listed in the vary header, it is a potential candidate for cache poisoning. Asterisk however, even headers in the vary header can sometimes be exploited if the backend application handles them incorrectly. 5. Referrer header manipulation asterisk. Asterisk the referrer header is often used for analytics or security purposes. Try setting it to a malicious URL, example a domain you control, and see if it affects the response. Asterisk this can be used to inject malicious links into the cached content. 6. User agent header manipulation asterisk. Asterisk the user agent header identifies the user's browser and operating system. Try setting it to a malicious value that could trigger different code paths in the backend application. Asterisk this is especially effective if the application uses user agent sniffing for content adaptation. 7. Host header manipulation asterisk. Asterisk the host header specifies the domain name of the website. Try setting it to a different domain or IP address to see if it affects the response. Asterisk this can lead to redirection attacks or other unexpected behavior. Phase 3, confirm cache poisoning. 1 Initial request with payload asterisk. Asterisk send a request with the identified unkeyed header or parameter set to a malicious value, the payload. For example, to verify the cached response asterisk. Asterisk send the same request without the malicious header or parameter. Asterisk check the response to see if it contains the malicious payload. Asterisk if the response contains the payload, it confirms that the cache has been poisoned. Asterisk look for the X cache, hit and age headers to confirm it's being served from the cache. 3 Test with different browsers/users asterisk. Asterisk to ensure the poisoning is effective for other users, test the same request from different browsers, devices, or IP addresses. Asterisk clear your browser cache before testing. Asterisk use a tool like curl or UGIT to avoid browser-specific caching. 4 Monitor for unintended consequences asterisk. Asterisk before reporting the vulnerability, carefully monitor the website for any unintended consequences of your payload. Asterisk avoid causing any disruption to the website's functionality or data. Phase 4, Exploitation, ethically and with permission. Once you've confirmed a web cache poisoning vulnerability, you can exploit it to achieve various malicious goals. Remember to only do this on systems you own or have explicit permission to test. 1 XSS injection asterisk. Asterisk if the application is vulnerable to XSS, you can inject malicious JavaScript code into the cached response. Asterisk example, set the X forwarded host header to script alert, XSS/script. If the application uses the X forwarded host header to generate links, the malicious script will be cached and executed for other users. 2 Content injection asterisk. Asterisk you can inject arbitrary HTML content into the cached response. Asterisk example, set the X forwarded host header to h1 poisoned/h1. If the application uses the X forwarded host header to display content, the poisoned heading will be displayed to other users. 3 Redirection asterisk. Asterisk you can redirect users to a malicious website by injecting a redirect URL into the cached response. Asterisk example, set the X forwarded host header to evil.example.com. If the application uses the X forwarded host header for generating redirect URLs, users will be redirected to evil.example.com. 4 Information disclosure asterisk. Asterisk in some cases, you can use web cache poisoning to leak sensitive information that was not intended to be cached. Asterisk example, if the application uses the X forwarded for header to log user IP addresses, you could inject a malicious IP address that contains sensitive data. Real-world examples, simplified and conceptual. Asterisk example 1, X forwarded host header and URL generation asterisk. Asterisk scenario, a website uses the X forwarded host header to generate absolute URLs in its HTML. Asterisk vulnerability, the X forwarded host header is not part of the cache key. Asterisk exploitation. 1 Send a request with X forwarded host, evil.example.com to https://target.com/page.php. 2 The server generates HTML containing links like a href equals https://evil.example.com/resource. 3 This response is cached. 4 Subsequent users visiting https://target.com/page.php will see links pointing to evil.example.com. Asterisk example 2, user agent header and content adaptation asterisk. Asterisk scenario, a website uses the user agent header to determine whether to serve a mobile or desktop version of a page. Asterisk vulnerability, the user agent header is not properly validated, and a malicious user agent string can trigger a different code path that returns sensitive information. Exploitation. 1. Send a request with user agent, malicious UA to https://target.com/profile. 2. The server, based on the malicious user agent, retrieves and includes debugging information, example database credentials, in the response. 3. This response is cached. 4. Subsequent users visiting https://target.com/profile receive the cached response with the debugging information. Example 3, parameter manipulation and language settings. Scenario, a website uses a URL parameter, example lang, to determine the language of the page. Vulnerability, the lang parameter is not sanitized, and a malicious value can trigger an error message or a different code path that exposes sensitive information. Exploitation. 1. Send a request to https://target.com/page.php, lang equals script alert, xss/script. 2. The server includes the unsanitized lang parameter in the response, resulting in XSS. 3. This response is cached. 4. Subsequent users visiting https://target.com/page.php receive the cached response with the XSS payload. Mitigation strategies. Proper cache key configuration. Carefully configure your caching system to include all relevant request headers and parameters in the cache key. Avoid using overly broad cache keys that can lead to unintended caching. Input validation and sanitization. Thoroughly validate and sanitize all user inputs, including headers and parameters, to prevent XSS and other injection attacks. Context-aware output encoding. Use context-aware output encoding to prevent malicious data from being interpreted as code. Cache poisoning detection. Implement monitoring and logging to detect suspicious activity, such as unusual header values or unexpected cache hits. Regular security audits. Conduct regular security audits to identify and address potential web cache poisoning vulnerabilities. Secure defaults. Configure your caching system with secure defaults, such as strict input validation and limited caching of sensitive data. Principle of least privilege. Grant only the necessary permissions to users and processes. Keep software up to date. Regularly update your web server, caching system, and other software to patch security vulnerabilities. Implement a web application firewall. WAF. A WAF can help to detect and block malicious requests that attempt to exploit web cache poisoning vulnerabilities. Content security policy. CSP can help to prevent XSS attacks by restricting the sources from which scripts can be loaded. Tools. Burp Suite. A powerful web security testing tool with features for intercepting and modifying HTTP requests, including the Turbo Intruder extension for fast fuzzing. OWASP Zap. An open source web application security scanner that can be used to identify web cache poisoning vulnerabilities. Curl and UGIT. Command line tools for making HTTP requests. Custom scripts. Python or other scripting languages can be used to automate the process of sending requests and analyzing responses. Important considerations. Ethical hacking. Only perform these tests on systems you own or have explicit permission to test. Unauthorized testing is illegal and unethical. Impact assessment. Before attempting to exploit a web cache poisoning vulnerability, carefully assess the potential impact on the website and its users. Avoid causing any disruption to the website's functionality or data. Reporting vulnerabilities. If you discover a web cache poisoning vulnerability, report it to the website owner or administrator in a responsible manner. Web cache poisoning is a complex and evolving area of web security. By understanding the underlying principles and following the methodology outlined in this tutorial, you can effectively identify and mitigate these vulnerabilities. Remember to always act ethically and responsibly when conducting security testing.